And so so what we're going to do is we're going to use the information to try and calculate some probabilities, essentially, some estimates based on the data. Now, alternative to what I just mentioned, sometimes the data is only given as groupings because it's very difficult to record every single data point, particularly when you've got continuous data and you've got such a whole range of values. I mean, if we're talking about someone's height, you know, a height of 145.3 will be different to a height of 145.7, which will be different to a height of 146.9, but they're all around about the same height. And so as a result of that, these groupings the data could already be given as groups, and you don't know the individual values. And so if that's the case, we are trying to find a method in which we can estimate some probabilities based on some values that might be within the range of the groupings, not just at the endpoint. So really that's the focus. We start with this example. I'll let you fill in the relative frequencies and we'll go from there. Number, what's the total number? Anyone work that out? 120. So we've got 120 students. So the relative frequency is the number of students in that particular interval out of the total. So it can be given as a fraction. It can also be given as a decimal. So either or. But once you've got the first one, then the rest are pretty much okay to work through. Probability here that X is less than 170. You can see, having a bit of trouble with this thing. Less than 170. So we're going from here down. So adding up all those relative frequencies, or we can use complementary events and say 1 take 8 plus 5 plus 4 on 120. Either way, we should get 103 on 120. 155, between 155 and 175, so that's going to include this one and up to that one, all of those, or add the 4 relative frequencies. We should be getting 75. And then conditional probability, X greater than or equal to 150 given X is less than 70. So in this case, we want then between 150 and 170, and then divide by that condition. So that condition restricts the sample space. So between 150 and 170, have we done that one? No. 20 to 20 there, 87. And then we divide that by X less than 170, which we did calculate was 103. Now you could simply just write that as 87 on 103 first up, or write your two probabilities. 87 on 120 divided by 103, 120. Regardless, that over 120 does cancel. All right, next one. Find K given the probability that X is less than K is 0.3. So the first thing we need to decide is what? How does that 0.3 relate to our table? Can't hear, sorry. Yeah, that's your total relative frequency. So from 0 up to a certain point. Yeah, so 0.3 related to this question, it makes it a lot easier if we actually have a value out of 120. What is 0.3? Well, 0.3 times 120 is 36. So in other words, 0.3 is 36 on 120. So what we're trying to do is count down to 36. And there's our stop point there at 155. So nothing too taxing there, hopefully. Where it gets tricky is the next one. So what's happening with the next question? we've actually got no idea where those 20 scores lie. In that interval, there are 20 scores. But we don't know, all 20 of them could have been 150 or 151 for all we know. We actually don't know. So we need to make an assumption. And we're going to assume that those 20 scores are evenly placed within the interval. That's what we do. So we assume those 20 scores are evenly placed. And we will always do that for any of these problems. Okay, so now we know we've got to interpolate, in other words, make a prediction because we can't be sure. We know we are going to make the assumption that everything's evenly placed. So how do we do it? How do we actually work out our value here? And I guess the point is this. You need to decide in that interval, the interval given is 150 to 155. The interval that you are being asked about is 150 to 152. So you've got an interval width of 5. 150 to 155 is an interval width is 5. So that is this, how wide each interval is. So from 150 to 155. And then you've got your part, what we call the interval part. And the interval part is the fact that if we're going from 150 to 152, that has a size of 2, right? It's 2 units wide, or in this case, 2 centimetres wide. So we've got this fraction, 2/5 of the interval is where our position at 152 will stop. It's going to be 2/5 of that interval. So we then multiply that by, now if we multiply that by 20, we would get how many are included, how many in the interval are included between 150 and 152. So that'll tell us how many. So 2/5 of 20 is 8. Is that right? Yes, it's 8. So that tells us that 8 scores, we're going to make the assumption with this even spacing that 8 of those 20 scores are what we require, right? 8 of those 20. If we make this a probability, so you can either choose to do 2/5 of 20, or you could choose to do, well, that 20 is actually, that the frequency is 20, but the relative frequency is 20 on 120. That'll then give us the probability we want, which should be 8 on 120. So you've got an option. So you either find how many are in the interval, so 2/5 of 20, which I said was 8, and therefore the probability associated with that is going to be 8 out of 120, or you could write that straight up as the relative frequency of that interval. So the reason why I'm giving you the option is because there's a solution coming up later where you're given the relative frequency. I like to do it this because to me this is logical. I find how many in the interval, and then that's 8, and then that's out of a total of 120. So that's how we do it, really. That's it. The expected value. So in all the work that we've done with expected value and data, we've always put data in list 1. Well, if we've got a calculator handy, list 1, and then the relative frequencies would go into list 2. What happens here? Here we have a scenario where you've got an interval, not a score. So we use the midpoint, yeah. So we don't use 140, we don't use 145, we actually need to use the midpoint. So the midpoint is going to be halfway between the 2 endpoints, which is the median of the 2 endpoints. So add the 2 endpoints together, the 140 to 145, and then divide by 2. So that should be 142.5. So all of these midpoints would go into list 1. and the relative frequencies go into list 2, because they're your probabilities. Think about your probability distribution, right? Your scores listed against your probabilities, and then from there we can determine the relative frequency. Oh, sorry, not the relative frequency, the expected value. So list 1 and the frequency is list 2, yes. Which are the probabilities, right? And so according to something I prepared earlier, 160.54 is what we should be getting. So that's to 2 decimal places. No, that's not why there's a column, but yeah, potentially we could have another column for the midpoint. What's different about this one compared to the previous? There's no between things. What happens here, you've actually got a gap. Right? You've got a gap from 100 to 101. Now this is discrete data because we've got text messages, and you can't really have 100.5 or 100.2 text messages. But for the sake of where the data's been recorded in this way, because sometimes it is, and the reason why we're giving you this particular question is because this was an example given to us by Skizzer, and so we're going to go with what they've given us. So we can use the same process anyway, because we talk about this idea of Forks continuous. You know, we're making out it's continuous even though it's really not. But the point is this: what do? Between 100 and 101, usually we set up a relative, an interval, a class interval with the inequalities, so there is no ambiguity. And what we do is the inequalities will split halfway between the gap. So it will go up to 100.5 here, and then the next one will start at 100.5. And then we know we are in at that point. And then, of course, we've got to keep the intervals the same, otherwise it doesn't make sense and the data gets distorted. Now, the other thing is, we need to also be consistent with those inequality signs. So if we choose less than or equal to there, then we need to choose less than here, because the next one will be less than or equal to. You can't have the same, you can't have the overlap, sorry, that should be 150 here. So we include 150.5 in the next one, and so forth. We've got our class intervals. That allows us to do the histogram, because the histogram can't have gaps. So we don't go up to 100 and then have a gap at 101. We actually do need to make sure we plot this properly. And it is a bit of a technicality when drawing histograms, but we don't plot this at 50. We actually need to start at 50. That first thing, you have to go slightly to the left, and we graph that at 50.5. And so then our first interval goes to 100.5. So that one, we stop at 100.5. So the frequency is 5 there. So you've just got to show that you've moved to the left. It's very difficult for me to do that or for you to do it on the screen. If you had paper, obviously it's easier. Just make that distinction that it's not exactly on 100. It's actually slightly to the left. To the right, sorry, gosh, I don't even know my left from right. Right as you're facing it. Yeah, to the right of the line, sorry. So, look, it's so hard to do because it's only 0.5, right? And your interval is from 100, the gap on the graph is from 100 to 150, so to draw that 0.5 is almost on the line anyway. But we just try and make that distinction. It's a real technicality. It doesn't come up much at all. See, now it doesn't look like that's on 40. Gosh, and always use a ruler and one straight line. No scratchy business when you're drawing a graph. All right, so again with this idea of the text messages, what's the probability that someone receives a text message, receives between 100 and 250? So we need to think about the interval from the 100.5 perspective to the 250.5 perspective, and that's easy to do because we have it 100.5 to 250.5, so 40 plus 17 plus 13. And it's out of 90. So the tricky part comes because we want from 180 and 220 inclusive. Now, you've got to be careful with this because we want to go from 180 and 220 inclusive, but because we need to use that idea of that Forks continuity, we need to make sure we are going actually from 179.5 because that's how it's drawn on the histogram. Think of it like that. From 179.5. Now, the problem with this one is twofold. Apart from that, what happens between 180 and 220? What's happening there? Nothing? Well, if you have a look, it's across two intervals, right? It's across the first interval stops at 200. So we have to kind of look at what's going on from 179.5 to 200.5, that's the first interval. And then we've got the second interval where we're going 200.5 and then we want to include the 220. So it's got to be from 220.5. So we've got essentially two estimates there. You've got to work out how many messages are included from 179.5 to 200.5. And so think about that idea of the interval width and the interval part. So each interval has a width of what? So be careful because we've extended it from 50.5 to 100.5, so the width is 50. But the interval part, we're going from 179.5 to 200.5. That's 21. 179.5, so that difference there is 21. So you want 21/50ths of, in that interval, 17. So 21/50ths of 17 texts. And if we want to write that as a probability, it would be 17 out of 90. Whatever that is. And then the second one, so the interval width won't change because that should be 50 and consistent all the way through. But the interval part will be different. The interval part is 20 text messages. So this time it's 20 on 50, but in that interval there we have less text messages, or less frequency, sorry, not messages. We have 13. So the frequency is 13. And as a probability, we could write that as 90, on 90. So essentially what we need to do is take this and add to the other to get the final probability. The solutions are given here for you. .1371 recurring is what I'm getting here.